I've been witness to a lot of geniuses. We've been doing amazing things here. So clap hands for yourselves. Okay, so if you've never seen a maths genius, I think you saw some here today, and you're looking at one right now. I am a maths genius. Not just self-proclaimed, but proven maths genius. So, I studied mathematics at the University of Zim, where I did my honors, like 4-year program. I did it in 3 because I was that good. And then I came over and I did a BCom in quantitative management with UNISA. Yes, you can guess, I did it in record time as well. So I taught a bit high school maths, and then I thought, okay, you know what? Let me go explore the world. So I left and I went into software development. I'm a self-taught programmer, developer, and I was in the mobile payment space where if you dial like the Standard Bank to say star 120, you know, that kind of stuff, that's what we used to do. And it was great because I had a mathematical background. I got bored again, then I went off and I worked for a company in Las Vegas as a gaming mathematician where I was working for a certification lab where we would make sure that the gaming companies are not cheating you. So I'd verify their software, their math and stats models to make sure that they were on point. So I've got a 5-year embargo now where I can't gamble in any casino in the world because I know exactly what's going on in there. Yes. For slot machines, can I tell you the trick? Right? Okay, take your pens out, let me tell you. For slot machines. If you want to win slot machines, okay? Take your pens out quickly. Okay, but make sure you don't share this with anyone, right? Don't share. This is top secret, okay? Okay, so have you ever heard of combinations and permutations? Have you ever heard of them? Okay, right. So, the first one. That's the most important one, right? For slot machines. Okay, are you ready? Okay, so my first advice is don't play. Don't play, because I wish you knew the odds of winning. Mathematically, it's impossible, but they're designed in such a way that the house always wins. Okay, so after leaving the gaming industry, I became an actuarial analyst for one of the insurance companies here in South Africa, and then I retired. And then started my own company called Maths Genius Leadership Institute. So I've written 4 books. I've just written a 5th one recently, where I'm passionate about connecting maths with real life. Where if you're doing algebra, why are you doing algebra? Where can you apply it in your life? So, let me rewind now and go back to pi. Okay, so pi is one of the most intriguing numbers in the world. Debatably, because some people think phi is better than pi. You know phi? Fibonacci sequence? Have you ever heard of it? Yes, 1.618, where anything that is natural or anything that is beautiful, right, obeys 1.618, right? Like if you measure the distance from here to there, divide it by the distance across, or maybe your arm, this divided by that, you know, for a dog, for a snail, for what, and people have been harvesting the properties of phi in all facets of life. Some people use it to invest, where they look at the sharpness of the graph in terms of investments and using that. What's his name? Da Vinci used it in the Vitruvian Man. Do you remember that guy with 4 arms? Yeah. Yes. So even the Mona Lisa, he used those kind of proportions. So it's important that you understand these important numbers. Now with pi, it's an interesting number. I will not go into the facts of pi because I know you can always Google them and you know them. But I want to stress the fact that pi is not just an irrational number. pi is a transcendental number. You know what is to transcend? To transcend is to go beyond, right? So it's a transcendental number, like E, 2.71, you know that one, right? So go and find out what are transcendental numbers, okay? But you'll find that pi in itself actually enhances all the properties of all real numbers. Okay, so just go find out about that. Now, these days they're using pi as a proxy, as a measure to see how efficient a computer is. There's something called supercomputing. Please write that down. You might want to do that. South Africa recently won the World Cup of supercomputing. They were sponsored by HP in Germany. And South Africa was the most empowered team because it had the most girls. So that's very positive. So girls, I expect you to push and be the best you can be in maths. Don't be limited by anything. So supercomputing, right? To measure the processing speed of a computer, they use pi as a proxy. Also, pi is also being used to harness the power of what is known as pattern recognition. Because pi doesn't have any patterns that are going on. It's enigmatic in nature. No one understands where it's going to go, right? And as human beings, we've always been attracted to things that are higher than us. We've been always trying to get to infinity, trying to grow, because by nature we are growth animals, right? We're always growing. Whether you're a plant, whether you're a human being, there's some growth of some sort, whether it's financial growth, spiritual growth, physical growth, but human beings, for us to have meaning, we have to grow. So things like pi, we will always be attracted to those kind of numbers because they take us into something that is beyond us. Because right now we're all wondering, yes, we've got 12 trillion decimal places for pi, but when are we going to get a pattern? When are we going to get recurrence? We're all wondering. And that curiosity which killed the cat is what keeps us going. And I don't think we'll stop anytime soon. So, I will not dwell on the decimal points of pi, because you can all Google it. I am going to say the most important thing in the math class now, when you go back to school, right? The most important thing in the math class is to say, whatever it is that I'm doing at any given time, how can I connect it to my reality? Personalize the math lesson in such a way that it's about you, it's about your reality. Because one of the biggest sources of disengagement, right? The reason why people hate maths is because they don't see the point of doing it. You understand? But you find that maths is all around us. And then, the fact that people can't get the meaning of maths in their own lives, they leave it and then they go for maths literacy or other things, right? Now, most of the stuff that you learn in school is not mathematics. It's just arithmetic. Do you understand? Most of the math that you learn in school is arithmetic, where you are number crunching, your what, but mathematics is bigger than that. It's not just about the numbers. It's about the thinking methodology as well, the way you think. Given a problem, can you solve it? So, mathematics is based on a duality principle. Duality, where for every problem, there exists an answer. That's why we are plotting and trying to get the answer to the enigma that pi has. So, for every problem, there exists a solution. Are we together? Now, in mathematics, it's like a simulation of life. Because if you ask yourself, what's the point of doing, from grade 1, doing a series of problems, What's the point? You know? So, it's like a simulation of life. In every day in life, you have to solve a problem. Isn't that true? In every day, you have to make a decision. Isn't that true? Right. So, do you have a structure in your thinking when you're coming up with solutions to problems in daily life? Do you have a structure when you're making decisions? So, mathematics, if you look at it as an analogy of life itself, you will find that, first of all, the problems, they start easy, right? They start easy and they get difficult as time goes on, but by the fact that you have actually mastered those principles, it carries on and you can actually achieve, right? You can actually keep getting solutions as long as there's some learning, continuous learning that is going on, learning from your mistakes. That is the same thing, right? Look at Mark Zuckerberg. I was just fortunate that last year in October, I shared the stage with Mark Zuckerberg in Atlanta. So that's my bragging point, yes. So, now if you look at Mark Zuckerberg, what did he solve? That guy is a mathematician. He didn't need to calculate anything, but he solved a real life issue. And he used mathematical principles, but what he did was he went down to the fundamental human needs. He said, what do people really want? People want to connect. People want to showcase whatever achievements they are getting, right? People want to connect, people want to communicate. So he used what are known as neural networks. It's a part of mathematics. It's very new. It's being used in telecommunications quite a lot. Neural networks. And then he used a simple philosophical principle, the principle of 6 degrees of separation. Have you ever heard of the 6 degrees of separation? So he said to himself, if I can reduce the 6 degrees of separation to 2 degrees, then I'll have achieved my dream, my goal. So 6 degrees of separation says that you are 6 people away from anyone in this world. It's like the interconnectedness of the universe. Together we're all connected. But now with Facebook, I know someone who knows you. Do you know that I know someone who knows you? If I go onto my Facebook right now and I search diligently, I'll find someone who knows you. That's how close we are. So he has brought us closer. That's why now we are a global village. And I like the setup at Allah here where I was hearing French, Portuguese, it was like, wow, this is how the world is supposed to be. So well done to people at Allah for allowing that. So, in mathematics, there's a guy in 1946, I think, he was a Hungarian mathematician called George Polya. Have you ever heard of George Polya? Okay, so George Polya came up with the skeletal system for problem solving. 4 steps. He said, the first thing, when faced with any problem or in any situation, the first thing is to understand the problem. I did a research recently with MISTRA, it's called Mapububo Institute of Strategic Reflection, where we were trying to find out what is the major driver for people failing mathematics. And we found that the fact that people don't take time to understand the problem is the major issue. What do I mean by understanding the problem? It's asking yourself questions like, what information am I given? What am I required to do? What is the objective? What information, oh, I said that already, right? Okay, that was a rewind. Okay, what is missing? What is what? You're like paraphrasing if given a question, right? Say a word problem. You're asking yourself all these questions to see what it is that you really have to do. So that's the most important thing, understanding the problem. Then, the second thing after understanding the problem is coming up with a plan. Coming up with a plan. Now, in maths, the plan that you have is, which formula am I going to use? Which method am I going to use? Can I have an alternative method? That is the planning process. And then from there, once you devise the plan, You carry out the plan, because what good is a plan if it's not carried out? You carry out the plan, and then the second driver to why people fail is that people don't evaluate. Now, this evaluation is equally important. To say, okay, fine, I've done all the steps, but the last one now, did I do it correctly? Did I put a plus where I was supposed to put a minus? So it's always important for you to check your work and get the feedback, if it's positive or negative. Do you know that if you can master those 4 steps in your thinking, in your decision making, right? If you can master that, you can go into any field. I'm telling you, business analysis, for example, project management, for example. It's those 4 steps, but now put in a flowery way. Companies like McKinsey, they've made billions and billions of dollars telling people how to do these 4 steps. They come in, they say, okay, the sky is blue, the grass is green. They say it in a structured way, and people pay them lots of money. So it's a skill that is missing in a lot of people, that if you have got that, then you've got mathematics. So mathematics is not just about the calculation. Mathematics is about purely understanding what the problem is. If you look, there are a lot of people who are trying entrepreneurship, right? And you find the person says, okay, I've seen that in South Africa, there are 2 billion dogs. And if I go into the dog food manufacturing, I'm going to be rich. I'm going to make it. I'm going to have a thriving business. But if you ask yourself, does it mean that if there are 2 billion dogs in South Africa, it implies that you are going to be successful? If you look at the competition, if you look at the behavior of the people, this is the understanding of the problem part, right? You see, I'm shying away from calculating things. I'm trying to give you real life situations, you understand? Where this guy thinks he's going to make it just because there are 2 million dogs in South Africa. But is that a given? It can't be, right? It can't be. So it's important for you to actually, before even understanding the problem, to identify if there is a problem. Now, worldwide, there's a problem now in the schooling system where you're in a maths class, you are given a question, right? Do you know what they're doing by that? They are robbing you of the opportunity to actually find the problem yourself. And finding a problem is actually a skill that is lacking in the world right now. So, when your teacher gives you a problem, right? Sorry, teachers. Make sure, try and see if the teacher's problem is really a problem. You understand? Try and see what's the rationale behind it. In your reality, where does it come in? Right? So the challenge now is that you're learning pi, you're learning e, you're learning phi, you're learning equations, algebra, all that stuff. But how can you use that algebra to change your community? How can you use that algebra to actually bring meaning to your life? Those problems that you're having in your community, how can you use the maths to come up with that? That's where mathematical modeling comes in, because it's very, very important. Are we together? So I don't have much time. I could have gone into detail with a lot of things, but if you want to hear a lot about my thinking, you can go on YouTube. It's Edzai, Edzai, and then my surname is ZVOBWO. ZVOBWO. It's such a Russian surname, yeah. Okay, so thank you very much for having me here. But I hope that whatever it is that you learn in class, you're going to use it somewhere, somehow in life. Because these are the people that companies want, people who solve real life problems. Thank you very much.